Hi all. So today we are going to discuss a very important section from the chapter waves, and that topic is harmonics. Correct? That topic is harmonics, and it is a very important section, a very high yield section from this chapter, right? So we know that there are three main instruments which we deal with in this chapter, which are an open pipe, a closed pipe and a string. Open pipe, closed pipe and a string. At first we will see what is an open pipe and the various cases. Then we will see closed pipe and its cases, and then we will see the string and its cases. At first let us draw an open pipe. See, what do you mean by an open pipe? An open pipe will have its both ends open. Both ends open means open pipe. Only one end open means it is a closed pipe. So both ends are open, and therefore this is an open pipe. Correct? This is an open pipe. So in an open pipe, you know that when it is open, at the open ends you will get antinode. At the open ends you will get antinode. Therefore this is an antinode, this is also an antinode, and this is a node. So this is the case with an open pipe. An open pipe will have two ends open. It will have at its free ends antinode, and in the center it will have a node. So what is this? Actually we are having first mode, second mode and third mode. What do you mean by mode? Mode means what I can say, level 1, level 2, level 3, like that. Mode 1, mode 2, mode 3. In the case of an open pipe, now let us draw the second mode. How the second mode will look like? Please see here. I will draw my second mode here, and we will draw the third mode here. So this is an open pipe. An open pipe will have its both ends open. Correct? See, here I had one node and two antinodes. Now what about the second case? In the second case I am having two antinodes and two nodes and three antinodes. Now what about the third case? In the third case we are having look how many nodes we are having. Node, node, node. 3 nodes and 4 antinodes. 3 nodes and 4 antinodes. Now please look here. In the first mode means what? Level 1 or mode 2, mode M-O-D-E. I will write it down here so that there is no confusion. You will take this as mode 1. This will be mode 2. And this will be mode 3. Correct? Mode 1, mode 2, mode 3. First case I am having one node and two antinodes. In the second case I am having, say, I am having two nodes. In the second case or second mode I am having two nodes and three antinodes. And in the last case I am having 1, 2, 3. 3 nodes and 4 antinodes. So what did you understand? The number of antinodes is equal to number of nodes plus 1 in the case of an open pipe. So we are dealing with open pipe here. Because the two ends are open. In the case of an open pipe, number of antinode is equal to number of node plus 1. Number of antinode is equal to number of node plus 1. Correct? Now let us see. You know that the distance between a node and an antinode is lambda by 4. Now you will see that here. So this is a node, this is an antinode, and this is node. You know that this entire length is lambda by 2. So half of that, a node to antinode, the distance will be lambda by 4. So the distance between a node and an antinode is lambda by 4. Now please look here. I am having an antinode, node, antinode. So what will be the length there? What will be the length there? The length there will be, please look here. First case, antinode, node and antinode. So the length will be L is equal to, how many lambda by 4? 2 into lambda by 4. So here the length is 2 into lambda by 4, or I can take it as lambda by 2, correct? In the first mode, length is equal to lambda by 2. Now see here, lambda by 4, lambda by 4, lambda by 4, lambda by 4. 4 into lambda by 4. L is equal to 4 into lambda by 4. Now see the last case, 1, 2, 3, 4, 5, 6. So here in the third case, length is equal to 6 into lambda by 4, 3 lambda by 2, or here it is 2 lambda by 2. So what did you understand? Length are as multiples of lambda by 2. So whenever you take the length of an open pipe, length of an open pipe will be multiples of lambda by 2. L is equal to lambda by 2. Is it clear? Length is equal to lambda by 2. Now we will be discussing, if we have found length, then what is the relation between frequency? How will you find frequency? See, you know that velocity is equal to f lambda. Velocity is equal to f lambda, or f is equal to, frequency is equal to v divided by lambda. See, look here. So here lambda is equal to 2L. From the first thing, from the first equation, we will understand that, see, lambda is equal to 2L here. Lambda is equal to 2L. Now in this case, lambda is equal to L. Now what about this case? Lambda is equal to 2L by 3. Lambda is equal to 2L by 3. Now when you substitute for lambda, F1, you will be getting it as F1 is equal to V divided by lambda is equal to 2L. Now in the second case, you will be getting F2 is equal to V divided by, instead of 2L, in the second case length is L, so V by L, or I can write it as 2 into V by 2L. 2 into V by 2L, because it is V by L, and I am writing it as the multiple of the fundamental frequency or the first frequency, correct? And the last one, F3 is equal to, here it was 2 into V by 2L. Now again we will substitute V divided by, instead of lambda we will be writing 2L by 3. So instead of lambda, 2L divided by 3. Now you will see that all the frequencies are, we are getting all the frequencies as the multiples of V by 2L. Initially it is V by 2L, and then it is 2 into V by 2L, and the third one is 3 into V by 2L. So all of them are as multiples of V by 2L, and V by 2L is the fundamental frequency or the first frequency. See, let it be open pipe, or let it be closed pipe, or let it be a string. The first frequency we will call it as fundamental frequency. When you consider the case of an open pipe, you will find that all the harmonics are multiples of the, or all the frequencies are multiples of the fundamental frequency or the first frequency. See, the multiples of the fundamental frequency is called harmonics. The multiples of the fundamental frequency is called harmonics. Here we will observe that all the multiples or all the frequencies are multiples of the fundamental frequency and all the frequencies are present. See, you are having V by 12, you are having 2 into V by 12, you are having 3 into V by 12. So all multiples of fundamental frequency is present in open pipe. All multiples are present, or I can say that F1 is to F2 is to F3 is equal to 1 is to 2 is to 3, and I can write that all harmonics are present. All harmonics are present in the case of an open pipe. Correct? All harmonics are present in the case of an open pipe. Now, what about writing a standard equation? You know that all the frequencies are multiples of V by 12. Now, if you are considering nth mode, now see, this is the frequency in the first mode, second mode and for third mode. For first mode it is 1 into V by 12, for second mode it is 2 into V by 12, for third mode it is 3 into V by 12. Now if it is nth mode, then how can you write the frequency? For nth mode, the frequency can be written as the final equation Fn is equal to n into V divided by 2L. Fn is equal to n into V divided by 2L, and likewise you know that length is equal to lambda by 2, or length is equal to 2 lambda by 2, length is equal to 3 lambda by 2. For nth mode, length will be written as Ln is equal to n into lambda by 2. Ln is equal to n into lambda by 2. So in the case of an open pipe, when you start, at first we will think that an open pipe is having its both ends open. At both these ends antinodes will be formed, and in the center node will be formed. The second point is number of antinode is equal to number of node plus 1, and then we found the length of that. What was the length? Length is lambda by 2 for first mode, 2 into lambda by 2 for second mode, and 3 into lambda by 2 for third mode. So when you consider nth mode, the length will be n into lambda by 2, and that is our first standard equation. And now we know that V is equal to F lambda. See, V is equal to F lambda is a very standard equation in this chapter, waves. From that we will get that frequency is equal to V divided by lambda. Already we know that lambda is equal to L here, lambda is equal to 2L, lambda is equal to 2L, lambda equal to L, and lambda equal to 12 by 3. When you substitute, you will be getting the equations for frequency 1, frequency 2 and frequency 3. We observe that all these frequencies are multiples of the first frequency, and therefore we say that all harmonics, all the multiples of fundamental frequencies are present here. So we say all harmonics are present in an open pipe. Correct? So the entire discussion of open pipe is over here. And before that, what do you mean by overtone? Overtone. Over means the very next. Overtone. See, this is the first tone, this is the second tone, this is the third tone. First tone, second tone, third tone. First overtone means what? Next to first. Means first overtone is second one. Now what about the second overtone? Second overtone is the third one. So overtone means the next one. So which is the first overtone? Second tone or mode is the first overtone. So which is the second overtone? Third tone is the second overtone. Understood? So the very next overtone means the next overtone. You will be skipping that one. First overtone means it is the second tone. Third overtone means it is the fourth one. Understood? Right. Now we will start discussing in the case of a closed pipe. Let's see a closed pipe. Right. Now here, in the case of a closed pipe, you will observe that one end is open and one end is closed. Again I will draw the second, this is for finding the second frequency or the second harmonic, second mode. Okay. In the first case, I will start from here. So this is the fundamental frequency. Okay. So I am having 3 modes here. Like we said in the case of an open pipe, here also I am writing mode 1, mode 2, mode 3. Okay. So this is mode 1, this is mode 2, and this is mode 3. At first let us discuss about the nodes and antinodes. How many nodes do I have here? I am having one node, I am having one antinode. How many nodes do I have here? I am having 2 nodes and I am having 2 antinodes. Now what about here? I am having 1, 2, 3. Sorry, I am having 1, 2, 3 and 3 nodes and 1, 2, 3 antinodes. So what did you understand? In the case of a closed pipe, number of nodes is equal to number of antinodes. So this can be another question. In the case of an open pipe, number of antinode is equal to number of node plus 1. In the case of a closed pipe, number of node is equal to number of antinode. Now let's see the length. In the case of length, what is happening here? See, in the case of length, first one, you are having a node and an antinode. So what is the length here? Length is equal to lambda divided by 4. Now what about here? Length is equal to 1, 2, 3. So it is 3 into lambda by 4. Now what about here? 1, 2, 3, 4, 5. And here the length is equal to 5 into lambda by 4. Why did I take lambda by 4? Because the distance between a node and an antinode is lambda by 4. So we will see that one node, one antinode. So 1 lambda by 4. Here it is 1, 2, 3 spaces are there. So 3 into lambda by 4. Here I am having 5 spaces. So 1, 2, 3, 4, 5 into lambda by 4. And from all these I can write. See, please observe. First length lambda by 4, again 3 into lambda by 4, 5 into lambda by 4. So for the third one it is first mode lambda by 4. Second one it is 3 into lambda by 4. Third one. So I need a general equation, right? What will be my general equation? I can write that for Ln it is odd multiples of lambda by 4. Here it is lambda by 4, 3, 5, so next will be 7 and after it will be 9 and then it will be 11. So I will writing 2n minus 1 into lambda by 4. So this is the general equation for length here. Length is equal to 2n minus 1 lambda by 4. Okay. Now what about lambda? From all this we will be getting lambda also. So from here I will write, therefore lambda is equal to 4L. Here lambda is equal to 4L by 3. Here lambda is equal to 4L divided by 5. Or again I am having the general equation for lambda. So for lambda also I am getting a general equation which is lambda n is equal to 4 into length divided by 2n minus 1. Correct? When you substitute 1 here, so it will be 2 into 1 minus 1, 2 minus 1, 1. So lambda 1 is equal to 4L. So this is a general equation for lambda and this is a general equation for L. Now we will be finding the frequency. You know that the equation for frequency V is equal to F lambda and F is equal to V divided by lambda. Let's see that. So F1 is equal to V divided by lambda is 4L. Likewise F2 is equal to V divided by, here lambda is 4L by 3. Last one, F3 is equal to lambda is equal to, so F is equal to V divided by lambda and here lambda is equal to 4L divided by 5. So again you are seeing odd multiples of V by 4L as the frequency. See, V by 4L, V by 4L, V by 4L. You are seeing only odd multiples here and again I am writing the general equation for that. Fn is equal to 2n minus 1 into V divided by 4L. Fn is equal to 2n minus 1 into V divided by 4L. So this is the very important point here. You are having only odd multiples of the fundamental frequency here. What is harmonics? Multiples of fundamental frequency is called harmonics. In the case of an open pipe, I had all the multiples. You had V by 2L, 2 into V by 2L, 3 into V by 2L, and therefore we said that all harmonics are present in the case of an open pipe. In the case of a closed pipe, I am having only odd harmonics. See, the first one is V divided by 4L. The first one is V divided by 4L. Second one is 3 into V divided by 4L, and third one is 5 into V by 4L. So here you are observing only odd harmonics, and that is why F1 is to F2 is to F3 is equal to 1 is to 3 is to 5. Only odd harmonics are present. Only odd harmonics are present. Correct? Now let's deal with the third thing. So now we have completed an open pipe, we have completed a closed pipe, and we understood that in the case of an open pipe, all harmonics are present. In the case of a closed pipe, only odd harmonics are present. Now in the case of a string, let's see the string. What is the difference between string and an open pipe and a closed pipe? So string, I'll write that mode 1, mode 2 and mode 3. We will be having the boundaries here, and definitely in the boundaries only nodes should be formed. So we are drawing it. So this is our fundamental frequency or the first frequency, and second one will be the second frequency or the first overtone. That is what we call here first overtone. Okay, let's see. Now how many nodes I am having here? Node, node. How many nodes I am having here? Node, node, node. Correct? Now again here I am having 1, 2, 3 and 4 nodes. So in the case of first mode, mode 1, I am having 2 nodes. Here I am having 3 nodes. Here I am having 4 nodes. Now what about the antinodes? I am having a single antinode here, 2 antinodes here, correct, and I am having 1, 2, 3 antinodes here. In the case of an open pipe, number of antinode was equal to node plus 1, but in the case of a string, number of node is equal to number of antinode plus 1. So in the case of a string, number of antinode will be more, correct. In the case of a string, number of nodes will be more. Number of node is equal to number of antinode plus 1. But in the case of an open pipe, we had number of antinode is equal to number of node plus 1. That is the only difference between closed open pipe and a string. Now let's see what is the length here. First thing that we observe in every case is length. First case, length is equal to lambda divided by 4. In the second case, length is equal to 1, 2, 3, 4. 4 into lambda by 4. Right. In the third case, again length is equal to, see, 1, 2, 3, 4, 5, 6. So 6 into lambda by 4 or 3 lambda by 2. Here it is 2 into lambda by 4. So I am getting it as lambda by 2. Here it will be 2 into lambda by 2, and here it will be 3 into lambda by 2. So all these are multiples of lambda by 2. All these are multiples of lambda by 2. Correct? So I will write a general equation for length here. So what will be the general equation for length? I can write length Ln is equal to n into lambda by 2. If it is first mode, it will be 1 into lambda by 2, second mode it will be 2 into lambda by 2, and if it is nth mode, it will be n into lambda by 2 will be the length, correct. Now let's go to frequency. How will we write the frequency here? V is equal to f lambda and f is equal to V divided by lambda. In the first case, lambda is equal to 2L. So V divided by 2L. Now in the second case, F2 is equal to V divided by lambda is equal to 2L by 2, which is equal to 2 into V by lambda, 2 into V divided by 2L. And in the last case, F3 is equal to again V by lambda, which is equal to F is equal to V divided by lambda. V divided by lambda is equal to 2L divided by 3. So it is 3 into V by 2L. Here it is 2 into V by 2L. And in the first case we had 1 into V by 2L. So you understood that all these frequencies, see 1, 2 and 3, all these frequencies are multiples of V by 2L. So what can I say? All the frequencies are multiples of the fundamental frequency, and therefore I can say that like in the case of an open pipe, here too I am having all the harmonics. All these harmonics are present in the case of a string also. So we will write F1 is to F2 is to F3 is equal to 1 is to 2 is to 3, and therefore I can say that all harmonics are present. All harmonics are present. Okay, so we know what is the frequency and we know what is length. What can be the general equation for frequency here? Like in the case of an open pipe, here also the general equation will be Fn is equal to N into V divided by 2L. So I think it is very simple topic, and it is a very high yielding topic too. The topic harmonics from this chapter waves. So we are just thinking about a closed pipe, an open pipe and a string. See, an open pipe and a string, they are almost similar. The only difference is that in the case of a string, number of node is equal to number of antinode plus 1. But in the case of an open pipe, number of antinode is equal to number of node plus 1. And in the case of a closed pipe, number of node is equal to number of antinode. Now what was the general equation for string as well as open pipe? The general equation for length is equal to N lambda by 2, N into lambda by 2. And the general equation for frequency is N into V by 2L, N into V by 2L. So that is the general equation for open pipe as well as string. Whereas in the case of a closed pipe, the equation for frequency is 2N minus 1 into V by 4L, 2N minus 1 into V by 4L. I hope that this section has become very easy for you, right?